Hai, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Yusaidah Alia binti Abdullah dari kelas DK4B. Nombor matrik saya adalah 11 DK19F108. So, pada hari ini saya ingin memulakan our lab simulation, iaitu impact of jet. In hydropower plant, turbines are utilized to generate electricity. These turbines rotate due to reaction force produced when one or more water jets are directed tangentially on the vanes or bucket that are fastened to the rim of the turbine disc. The impact of the water on the vanes generates a torque on the wheel, causing it to rotate and to generate electricity. The study of these reaction forces, which is the application of conservation of momentum principle, is an essential step in the subject of mechanics of fluid and hydraulic machinery. The objective of this experiment is to investigate the reaction force produced by the change in momentum of fluid flow as a jet of water striking a flat or curved surface and compare the results with the computed momentum flow rate in the jet. The apparatus for the study of momentum of a fluid flow is the impact of jet apparatus. Water enters a cylinder vertically through a nozzle and then strikes a target mounted on a stem. A wake pen mounted at the top of the stem allows the force of the water to be counterbalanced by applied masses. The issue from the nozzle, and after striking, the target plate leads through the outlet holes in the base of the cylinder. The vertical force on the target plate is measured by adding weight to the wake pen until the mark on the wake pen corresponds with the level gauge. Remove the top plate and transparent cylinder from the equipment and check or record the exit diameter of the nozzle. Screw the 90-degree deflector onto the end of the shaft. Connect the inlet tube to the bench quick release connector. Replace the top plate on the transparent tank, but do not fit the 3 kernel nuts. Using the spirit level attached to the top, level the transparent tank by adjusting the feet. Replace the 3 kernel nuts, then tighten in sequence to retain the top plate level indicated by spirit level. Do not over tighten the null nut, as this will damage the top plate. The nut should only be tightened enough to level the plate. With no weight on the wake pen, adjust the height of the level gauge until it aligns the datum line on the wake pen. Check that the position is correct by gently oscillating the pen. Place a mass of about 50 grams on the wake pen and open the bench valve to produce a flow. Open the flow valve slowly and allow it to open the target until the datum line on the wake pen is level with the gauge and leave flow constant. Observe and note the flow behavior during the test. Now measure using the volumetric tank. This is achieved by closing the ball valve and measuring the time taken to accumulate. And now volume of fluid in the tank as measured from the side glass. Repeat this procedure by adding an additional 50 grams each time until maximum weight of 500 grams is reached. Then repeat the whole test for each of the other flow deflectors. To change the target plate, undo the null screw on the top plate and remove this from the transparent tank. Take care not to over-tight the null screw when replacing the top plate, as this can damage the plate. When finished taking reading, replace the deflector back to the first one used. Be sure to clean up your station and any water that may have spilled. following. Complete the result table and put together on your lab report. Thank you. This is the data for impact of check. So firstly, we measure value for flat plate. So in the data we have forces, measuring time, average measuring time, flow rate. So firstly, in the data I get the forces and measuring time. So how to calculate the average measuring time is all the measuring time divide to 3 and get the average. So flow rate, measured volume, average measuring time. Okay, next, measured value for hemisphere, 180-degree deflection. So in the data we have forces and measuring time. So the average measuring time and flow rate we need to calculate. So average measuring time plus all the time and divide to 3. So we get the answer. So flow rate, also measured value divide to average measuring time. So we get the answer. Number 3 is measured value for cone, 135-degree deflection. So in the data forces and measuring time. So to calculate the average measuring time, we need to all the time and divide to 3. Also the flow rate is measured value divide to average measuring time and get the answer. Okay, this is the example of calculation for sample 1. Okay, this is the result for a flat plate. So flow rate in the data put on the result. How to calculate the velocity is Q per A, 1.28 exponent negative 4 per 5.03 exponent negative 5. So velocity is for sample 1 is 2.54. Similar for calculated force for flat plate, rho QV. Rho is density water. So density water is 1000 multiply 1.28 exponent negative 4 for flow rate and multiply velocity 2.54. So we get the answer 0.33. So the measured force in the data. The hemisphere also flow rate in data and measured force is in the data. So we need to calculate the velocity and calculated force. So velocity, let you also know Q per A, flow rate per area. So we get the answer and calculated force for hemisphere, 180 degree is rho Q to V. Rho 1000 multiply Q 9.26 exponent negative 5 multiply 2V is 2 in bracket 1.84. Get answer is 0.34. So the cone 135 degree deflection, also flow rate and measured force in the data. Velocity we need to calculate, but we also know the formula is Q per A. So calculated force for cone is rho QV in bracket 1 plus cos square infinity. For sample 1, 1000 multiply 6.1 exponent negative 5 multiply 1.21 is velocity. In bracket 1 plus cos square, so the infinity we convert to 135 degree. So the answer is 0.02. This is for discussion. First is comparison of the 4 bodies with completing the table below. We calculate the calculated force for plate, hemisphere, cone, put in the data. Second, plot the graph of force vs calculated force for different deflector. Discuss your graph result. So this I get a graph. So I plot what I get in data, I put on the graph. So the conclusion is what I got from this experiment is the experiment is carried out were successful, even though the data collected a little bit different compared to the theoretical value. The difference between the theoretical value and the actual value may mainly due to human and servicing factors such as parallax error. The error occurred during observer captured the value of the water level.